Intricate Devo, intricate.
Hey everyone, welcome back to Intricate Devo, the place where complex programming concepts become super easy and fun to understand. Today, we are diving into one of the most powerful concepts in the object-oriented programming, encapsulation. But wait, before we unlock this concept, hit the like button, smash subscribe, ring the notification bell so you never miss a future coding adventures. Imagine this. You own a bank account with a $1 million. Now imagine if anybody could directly access your bank balance variable and change it whenever they want. Scary, right? Someone could literally do this. Bank.balance equals 999999999 and boom, financial costs. That is exactly why encapsulation exists. Encapsulation is the process of wrapping a data and methods together into a single unit and protecting that data from the direct access. In simple words, hide the sensitive stuff. It's like keeping your valuable inside the locked wallet. Only authorized methods can touch the data. Think of an ATM machine. You don't have directly access to the bank database. Instead, you interact with the buttons and screens. The ATM check your PIN, it validates your balance, it enforces your rules, and that is encapsulation in real life. In Java, encapsulation starts by making a variable private string name. This means direct access is blocked, so this becomes illegal. My object.name equals John. Java says nope, not allowed. So how do we access private data? Using getters and setters. Getters read data, setters update data. Getter example: public string get name, return name. This method safely return the value. Setter example: public void set name, string new name. This dot name equals new name. This method safely update the value. Now here where the encapsulation become incredibly powerful. You can add a validation, meaning you control what data is allowed. Example: public void set age int age. If age greater than 0 and less than 150, this dot age equals age. So if somebody tries this empty dot set age of -5, the object says invalid age detected. Your data stays safe. What if you want data that can only be viewed but never changed? Easy. Provide only a getter. Public string get student ID, return student ID. No setter, no modification, completely read only. But wait, what if someone create an object with a bad data from the beginning? Like this, product P equals new product of -100. That's where constructor validation helps. Example: public product double price. If price greater than 0, this dot price equals price. Else, this dot price equals 1.0. Boom, your object start with a valid state. Now let's enter a pro level encapsulation. Suppose your class stores an array list. If your getter returns a original list, external code can secretly modify your internal data. That completely breaks encapsulation. Dangerous getter. Public list string get codes, return secret codes. Instead, return a copy. Safer getter. Public list string get codes, return new array list secret codes. Now your internal data is protected. That technique is called defensive copying. Why encapsulation matters? So, data hiding, better security, controlled access, validation, flexibility, maintainability, clean code, and most importantly, it protects your object state from becoming invalid. So remember this golden rule: never expose your data directly. Always control access through methods. That is the heart of encapsulation. And once you master this concept, you start writing professional Java code. If this video helped you finally understand encapsulation, drop a comment saying encapsulation mastered. Don't forget to like, share and subscribe to Intricate Devo. And remember, the more you code, the more powerful you become. We will see you in the next video.